In this video I want to tell something about the so-called single sideband, lower sideband, upper sideband, etc. etc. I made a shortwave receiver with, say, a so-called beat frequency oscillator. And the interesting thing about such a beat frequency oscillator is that via that BFO you insert a carrier wave into the intermediate frequency amplifier. For, say, single sideband and radio transmissions, often or more general, made by radio amateurs, but not alone by radio amateurs, you have the so-called situation that there is no carrier wave. So you must add, to make a transmission audible, intelligible, you must add the carrier wave inserted into the intermediate frequency amplifier. And this is an example. It's a very old video that I made in the past, but anyway, it shows how it works. So let's look.
Thank you very much. Bye-bye. Now Kilohertz, Sugar Papa, it's Golf Whiskey Italy.
This is my homebrew shortwave receiver. I want to show the functional units. This is the audio part, the loudspeaker amplifier. This is of course the loudspeaker. This is the beat frequency oscillator. It generates a signal between 451 and 458 kilohertz that's inserted in the intermediate frequency amplifier.
So I stop it now because this is interesting. This is the beat frequency oscillator. It goes between 451 and 458 kilohertz. That's inserted, and that means when we turn this beat frequency oscillator, you can receive the upper sideband and the lower sideband. So in many schematics that is in a certain way separated via crystal oscillators, but when you use this a separate unit that is variable between these two frequencies, you can receive via inserting that beat frequency oscillator frequency into the IF amplifier, you can receive the upper sideband and the lower sideband. In the Netherlands we call that a so-called zwevingsoscillator. Anyway, let's look further.
And it makes it possible to receive radio stations on single sideband that are transmitting on single sideband system. This is the VFO, the variable frequency oscillator. It generates a sine wave between 6.4 and 18 megahertz. And this is the fine tuning. With this I can tune to the exact frequency of the radio station.
It's very important to tell that when you want to receive say radio amateurs, or you need a fine-tuning on the VFO, the variable frequency oscillator, and you also need a fine-tuning in a certain way. You can see it here, fine-tuning on the beat frequency oscillator. So this is the fine-tuning here for the local oscillator that is responsible, say, for the super heterodyne reception, and here is the beat frequency oscillator that is responsible for receiving the upper sideband or the lower sideband or the middle sideband. And I have to say nowadays via the computer, via computer programs, you can receive all these more or less, say, different modulations that are used on shortwave. Anyway, computer programs that can detect the radio signal and etc. Anyway, I will give more info in the description.
This is the tuning capacitor of the antenna coil, and I can set this to the various frequencies that are needed. It gives a peak in a certain frequency band, and it makes it possible to receive weak stations especially. This is the high frequency amplification.
I'm talking about the so-called front end here. That is in a certain way the antenna amplifier. The antenna coil is used in this radio, and I can set the high frequency amplification here to say lift up that antenna signal in a high frequency way. Of course, no detection, that's not good, but anyway, say a high frequency amplifier, and normally it's named a front end amplifier in a shortwave radio.
Level, I can set it with this knob. I can also switch it off and on, and the reason is that this high frequency amplifier is not necessary for the lower shortwave frequency bands up to approximately 10 megahertz. This is the band switch. I can switch it between two frequency bands.
And I've made that band switch in a very simple way by shortcutting a part of the antenna coil. More information in many videos on my YouTube channel.
6.8 up to 15, 15 to 18 megahertz. And they correspond with this switch on the BFO. It can also be set to different frequencies.
That's of course necessary. There are two ranges, 6 to 8 megahertz and the other position. Anyway, let's go further.
I'm listening now to radio amateurs on 7 megahertz. It's the 40 meter band. They are from Italia.
And you hear what I name the so-called Donald Duck voices. But you can say tune that to say normal human voices by tuning the beat frequency oscillator. Anyway, I will do that, I think, in this video, as far as I can remember.
And you can hear them now. And I now want to demonstrate the different functions by tuning all the knobs. I now want to turn.
And it's very important to tell that you can insert that beat frequency oscillator frequency somewhere inside the intermediate frequency amplifier. It can be at, say, the first transistor or the second transistor in the IF amplifier. You can, say, insert that, say, 455 kilocycles or 457 kilocycles via a small, a tiny value capacitor somewhere in the transistor amplifier that does the IF job. Experiments will show you how to do that and how to find that out. Anyway.
Now turning the BFO, beat frequency oscillator. And you can hear that the voices change from Donald Duck voices to normal human voices by turning that knob and changing that frequency. I hope the Italian radio.
And here you can hear how, say, that beat frequency oscillator works in an analog way, of course. Like I told, nowadays computer programs can do that, but this is completely analog. And here you see the effect of, say, the mixing frequency. In Dutch we call that the zwevingsoscillator. The effect of the different frequencies that are sent into that IF amplifier in an analog way. And on a certain moment there is such a good relation between, say, the IF frequency of the IF amplifier and the beat frequency oscillator that the speech is intelligible, both for lower sideband and upper sideband. Anyway, let's listen.
Now it's set to the right frequency.
Okay, thank you very much. Have a great bye-bye.
I'm now going to demonstrate the fine-tuning. This is the effect of the fine-tuning to the emitters.
And this is indeed the effect of, say, the extra capacitor that's here inside, that is connected to the local oscillator, and this is a small value capacitor in the order of 50 picofarad. It's parallel to the local oscillator. So here you can fine tune, and that has in fact the same effect compared to the frequency of the beat frequency oscillator. So there is, say, a serious relation both in this way and both in that way. You can make, say, single sideband signals, radio emitters or other signals intelligible. But this video will stop within, say, a few minutes, but anyway, let's look to the final part.
Station.